Hello everyone, thank you for coming. Welcome to this session of NAUTO's 36th Annual Conference. On your attendee screen, you will be able to enter comments and questions in the audience chat. We hope you will take advantage of this opportunity to engage with our speakers. We recognize and thank our Petabyte sponsor, the California Healthcare Foundation. All conference sponsors have virtual booths available during the conference in the sponsors section. At the booths, you can learn more about the sponsors, review materials, request contact, and collect game tokens. We hope all attendees will take a few minutes to visit each sponsor's booth. Now I will turn the stage over to Charles Hawley, NAUTO's Director of Projects.
Thank you, Maureen, and thank you all for joining this session on innovations in data infrastructure and processes to support policymaking. I am excited to introduce our sponsor is the Mercatus Center at George Mason University, and I'm actually going to have Elise Amez-Droz give a brief introduction to this session.
Hi, everyone. Thank you so much for joining this session on innovations in data infrastructure and processes to support policymaking. My name is Elise Amez-Droz. I'm the program manager for the healthcare team at the Mercatus Center. We are a university-based research center at George Mason University in Arlington, Virginia. And we've been here for 40 years now. We just celebrated our 40th anniversary. And our research focus is not only on healthcare, but on all kinds of economic issues that have to do with policymaking. And recently, in the past few years, we've been diving into healthcare data, focusing specifically on healthcare regulations and quantifying them using machine learning and AI. And so this is why this session is so important to us. We believe that there are lots of insights that can be uncovered by using machine learning to read regulations, to understand better how they influence the policymaking process and ultimately patient outcomes. So we're really excited to dive into these different topics that we have today, and we have a very packed schedule in this session. So very excited to see how it goes and to discover the different ways that we can use new innovations in data processing to implement better policy solutions for patients around the country. And with that, I'll hand it over to Mary Jo Condon, who's a senior consultant at Freedman Healthcare.
Thank you, Elise, and welcome everyone to this exciting session. As I was meeting with our panelists virtually and listening to their presentations, I was really struck by the amount of work that has gone in to making the data ready for policy analysis. And so I think you're really going to be impressed by the work that you learn about today, and also have some good takeaways to apply to your own work. So we're actually going to start with turning it back over to Elise in just a minute. So Elise and her colleague, Kofi Ampaabeng, are going to be talking about, as she mentioned, in the inventory of healthcare regulations, machine learning and other approaches. So Kofi and Elise work to identify and really quantify healthcare regulations that apply to various topics and sectors. And interestingly, they did this through a combination of artificial intelligence and also a lot of manual lift that they'll tell you about in a few minutes as well. I think the outcome, though, is really exciting. It's a database of federal and state healthcare regulations that span various topics and can be used for a wide array of compelling analyses. I know I'm looking forward to diving in there myself. Before we get started, just want to talk to you a little bit about our presenters. And so Kofi Ampaabeng is a senior research fellow and a data scientist at the Mercatus Center at George Mason University. He specializes in curating data and really generating relevant policy insights from that data. Elise Amez-Droz, as noted during the introduction, she's a program manager of the healthcare policy program at the center, and she's also a member of the millennial cohort of AEI's leadership network and a senior contributor at Young Voices. So with that, I will turn it back over to Charles to play our first video.
Hello and welcome to our session today. My name is Kofi Ampaabeng, and I'm here with Ms. Elise Amez-Droz, whom you heard. We are from the Open Health team at the Mercatus Center. And today we're going to be talking about healthcare reg data, classifying healthcare regulations into topics. We're from the Quantitative Health Lab, like I said, and our goal is to be the one-stop platform for healthcare regulations and analysis. And we are starting that with healthcare reg data, which we're going to be talking about. We're going to start with a quick overview of health reg data. Then I'll walk you through the methodology, how we end up producing the data, then a brief preview of the preliminary results that we have. Then Elise will come in and talk to you about how you can use the data, including how you can work with us if you need to. And finally, I will talk to you about two things we are excited about, which is a markup language called X2RL and RegHub, which is a repository of healthcare regulations, of all regulations, including healthcare. So what is healthcare reg data? Last year at NIDO, we introduced healthcare reg data, and essentially it has three things, which is one, from the body of regulations, we try to identify healthcare regulations. And so if you go to state X that has the administrative code that regulates activities, we have an algorithm that goes in and picks out healthcare regulations. Then after identifying these regulations, we actually measure the volume of regulations. And so we develop a metric which we call restrictions and account obligations in the regulatory code. Using that, we are able to measure the volume of regulations in a jurisdiction. And not only that, you can determine the industries that are most likely to be affected by the regulations that we've identified. And so from that, we showed you this graph which says for a number of states, these are the industries that are most likely affected by the healthcare regulations on their books. Fast forward to today, or at least even from the very day that we presented these healthcare reg data and our interactions with other researchers, they always ask you more questions. Oh, so what's the most burdensome regulations that apply to X, Y, Z? And we use Medicare as an example, which is a query we received from a researcher. And that is what we're going to try and present to you today. Then there are other things that we are not able to answer yet, but we are getting there, and which is what are the specific features of the regulations? So for example, when it comes to occupational licensing for healthcare professionals, can we identify the cost, the fee, the renewal period, the educational requirement of these regulations directly from the text and make them available? And that is the next step in our process, and we'll talk about it later. So to summarize, we identify regulations, we classify them probabilistically into 12 topics, and then we apply the tools that we've just talked about to actually measure the volume of regulations. And so similar to the industry relevant restrictions, we now have topic relevant restrictions, which are then useful for research. And the way we do it is kind of straightforward, using the typical machine learning and text analysis. But our first step is to get data. And so we've written scrapers for all 50 states and the district. And so we scrape the data from their site. Actually, I should correct myself. There are a few states that we are unable to scrape the data because the statutes or the administrative codes are hosted by third parties such as LexisNexis. And so for that, we cannot scrape. And there are about 4 of them. Once we get these data, we then determine the unit of analysis. And that is important because the classification we are trying to do is most accurate when we do it out for a small unit of text. And it is also typically the way people reference regulations or text for that matter. And so the typical regulatory code or statute is divided into title, chapter, section, even though the language is not exactly the same, that's the sequence. We are most interested in the smallest unit, which is the clause. Once we do that, we then define the healthcare topics. And the way we arrive at the healthcare topics of interest, the 12 that we did for today, is just a combination of machine learning algorithms to sort of classify or cluster these results together. And then also from our own researchers that have studied specific things like certificate of need laws, scope of practice regulations, we sort of put these together to put out these topics. We create a training data, which is just select from randomly from a number of states, humanly, we use humans to classify them into these topics. And then we build the algorithm and then we run it on the entire code. So here are some preliminary results from this process. And here I'm going to show you the raw output. Here is a text from the Alabama code and actually the statute. And we know that it's talking about certificate of need. So we've actually highlighted that. And these are the probabilities that this particular text applies to these topics, these healthcare topics. And we see that certificate of need comes up top with the highest probability. These probabilities don't sum up to 1. Sometimes I have to clarify. It basically just look at the probability that the text here applies to this particular topic. And there are a few others in there that the language might be similar, but it's exactly not pertaining to these topics, right? And some are outright 0, at least to the 3rd decimal place. So this is really the raw data. We normally summarize this into the industry relevance or the topic relevance that we talk about. But just a quick one about some of the limitations of this data. As most of you are aware of, you interested in healthcare, there are so many different topics that we cannot possibly enumerate all of them. And here we basically selected the ones that are most relevant for us. We are going to keep increasing as time goes on. Also, we only scrape the data for 2020, so it's 1 year. So in a way that limits some of the analysis that we can do, but it's a start. And third, it is probabilistic, which means is we are using the probability that the text applies to the particular topic. It is not like deterministic. Next, we're actually going to be working on longitudinal. As much as possible, we will go and scrape data from previous years. And then even more important, the question that we could not answer in terms of the specific features, we're actually working on information extraction algorithms to actually pull all these data for people. Accessing the data is easy. Go to our website, Condon, and you can actually download those and other data that we have. We've built an API that is pretty robust. And so you can access the API and pull all the data. Or you can use our Python package, which calls the API for you. You can view our video tutorial. If you're more comfortable with R, we've also got an R package for you, and you can access all the data we just talked about today. And with that, I'm going to hand it over to Elise, who will talk to you a bit more about how you can use these data for your research.
Thank you, Kofi. So yeah, I would like to quickly tell you a little bit about how you can use that data and work with us using this data. So first, obviously, you can locate all healthcare regulations that we found using RegHub, which Kofi will describe in a moment. And you can use these data in analysis. So you can start using it to, or using them to examine the impact of regulations on health outcomes. So for instance, can we see a correlation between the burden of regulations or the volume of regulations regarding Medicaid in one state and their the number of medical deaths, maternal deaths that happen there? Or do we see a correlation between rehospitalization rates and the volume of regulations in a given topic? So that's one way. And then we would love to partner with you. So we can collaborate on research together. If you have an idea for a research paper or a research question that you'd like to answer, please let us know. We'd love to help you find the right data and work with you to make that research happen. And if you have suggestions for other topics that we should be looking at, please let us know as well, because we're looking to expand that list of topics like Kofi said. So please don't hesitate to reach out to us.
Thank you, Elise. And so here are the two other things that we said we're excited to share with you. And that is, the first one is the RegHub. RegHub is really a repository of all the regulatory text that we've extracted, including the statutes and the regulatory code. And we've cleaned them up and put them in a searchable form on our website. You can log in, go to reghub.ai, get an account, it's free, and then you can actually search it. You can search data across all jurisdictions. And so here is a snippet where I'm searching for mining. And so you can see all the regulations that pertain to mining. This is a work in progress. We're adding more features, so you can actually do a topic analysis, all the things that we did today, you can actually use that for that. And then there's also XURL, which is even more exciting. One of the reasons we've had to do this topic modeling is the fact that you can't really tell who, or at least from a machine perspective, who the regulations apply to. What we're trying to do is we've developed a standard or a markup language that would actually let regulators or people who write regulations be able to talk about the effect of a particular regulatory, units of code. So in our example, we're using clauses. You can actually pick what are the effects of this clause, who is the target of this clause, and from where the clause derives its authority from. Thank you for being with us today. You can always contact us directly by email. Elise is always going to be ready to respond to you as well. Thank you.
Well, excellent. Thank you both so much. And we already have some questions coming in. So Imelda Flores asks, why do you think the Medicaid category has a probability of 0. So if we go back to that slide in which you showed the results from Alabama, what do you think is happening there?
So basically, it's a feature. Thank you for the question, Imelda. It's really a feature of the words that the algorithm sort of came to associate with that particular category. And if you look at that particular code, I know because I read it, it basically is specifically talking about certificate of need, which is a facility licensing, and it is not directly related to Medicaid at all. So one of the things we're doing is we're running this on sort of the entire code to actually see exactly how it will classify the regulations. And so if we have another text, we can actually try it. Let's say it's surely Medicare and see how that works out. Unfortunately, we do all of that in the background. We haven't sort of front-ended that particular part yet, but it's something to consider.
Excellent. Another question. So can you talk to us a little bit about how you handle instances where one state might call something different than another state? And what kind of work did you need to do to kind of standardize terms?
So that's a great question. And it's really one of the biggest challenges is states call things differently. We spent a lot of time reading regulations for this particular task. And so what we try to do is to, when we build the training data, select for a particular topic data from as many different states as possible. So that's one approach that we use, including the data. That should help somewhat. It's not perfect, but at least if we get a variety of states on a particular topic, that should capture as many of the languages as possible. What you try to do, especially when it comes to machine learning projects, is not to do what we call overfitting. So if you put in too many of them, it learns from it and it may not be applicable. So we had to strike that balance between just enough to get good results and also not, have a very bad bad model.
That makes a lot of sense. Well, thank you both so much for an excellent presentation. And Charles, I'm thinking we may want to move to our next presentation just in light of time to make sure we can get all 4 in and have some time for questions for each of them. All right. So our next set of presenters is Natalie Helbig and Joseph Newell. And Natalie and Joseph are going to be talking with us about how they utilize New York's all-payer claims database to fill in some really important information gaps. What I thought was so fascinating about this is how they were able to really creatively and quickly work on the fly to take an existing data set and essentially change the submission schedule and start grabbing data more quickly so that they could inform policy. I think one of the challenges that we all face sometimes when we're working with data is knowing whether or not the data is good enough to use for the purpose at hand. And sometimes we're willing to use data that maybe isn't as perfectly complete or perfectly analyzed because the policy need really requires it. And that's what we're going to hear about today from Natalie and Joseph. It's actually also what we're going to hear about today from Brantley and Sterling in just a few minutes. So to tell you a little bit about Natalie and Joseph, Natalie Helbig is the Deputy Director of the Division of Health Data Innovation. Prior to working at the Department of Health, Natalie was the Assistant Research Director at the Center for Technology in Government at SUNY Albany. Joe Newell is Senior Manager of the Technical Projects and Program Management at Optum, and he oversees the data intake for the statewide planning and research cooperative system, also known as SPARCS. SPARCS collects data on patient-level characteristics and diagnoses. All right.
So briefly, the overview of the all-payer data warehouse, we have an intake system that collects encounter and claims information, as well as hospital discharge information. Our hospital discharge information collects data from over 400 facilities, 200 acute care hospitals, and the data is able to be submitted by those hospitals regularly. We have a warehousing and enrichment environment that allows us to create a master patient index. We can do enrichment to the data for address standardization and geocoding, and then also augment the data with reference files as well as analytic tools for categorization and grouping of various kinds of medical procedures. We then can offer research and analytics. You'll see most of it revolves around quality measurement and patient safety, population health and utilization, as well as cost and price transparency. And we have an ability to have folks access the data through an APD analytic portal that we'll talk about in a little bit, as well as a public site called the New York State Health Connector. And we also deliver data extracts of hospital discharge data to the various kinds of stakeholders that need the data for research and other kinds of analytics. This is just a picture of the all-payer data warehouse. On the left-hand side, you'll see the Sparks data submission system. As I mentioned, in 2017, we started to modernize that system because it was, for the last 20 odd years, it was a mainframe COBOL system that generated the data for us, and the hospitals would submit through our health commerce system. In 2018, we went to production with Optum system that we'll show in a little bit, and that really brought us, a modernization effort that allows us to take advantage of more agile type of technologies. So just to give you an idea of the overview of the hospital discharge regulation that was done back in probably 10 or so years ago, hospitals are required at a minimum to submit on a monthly basis. And that regulation was put in place when monthly was actually very timely. As we'll see going forward, we've improved that time frame so that we are at a daily submission of hospital discharge information. Hospitals are also required to submit at least 95% of the data within 60 days from the end of a patient's discharge. And that reason that's important is because it is a discharge system, which means that their length of stay matters, right? So some patients are in the hospital for a day, some are in the hospital for 45 days. And so we don't get that information until the patient is discharged. And even after that, there's a requirement that they report 60 days from that discharge date. The overview of the submission system really shows just its basic components. The submission portal through Optum's clearinghouse is open 24 hours, 7 days a week. The data is processed, translated, enriched, and promoted to our Sparks data model on a daily basis. And as I mentioned, this system modernization started back in 2017 with it going into production in 2018. That modernization effort allowed us to accelerate processing during the pandemic. So you'll see the processing went from 1 week to 1 day. And we were able to bring the data in and put in the environment and then create visualizations to start to look at how data was coming in over time. And this allowed us to provide to stakeholders a snapshot of what was happening in hospital capacity-wise as folks were looking at different areas of need. What you see in this picture, though, is that there is a 9-day length of stay. If they were admitted on September 6th, their discharge day is on September 15th. That's a 9-day natural lag or length of stay. And then our regulation imposes the extra time of not having to submit until 60 days post the end of the discharge day or the end of the discharge month, which is September 30th. So right there, you've increased lag in the data, and it's not just about the technology being able to capture the data. There's also business processes that have to be taken into consideration when we talk about real-time data use for policymaking. One of the things that was a benefit prior of the pandemic was that we were able to get hospitals to submit data and then also have our vendor Optum process that data within 1 day. Prior to modernization, we had processed data monthly, and it took about 2 weeks to translate, enrich, and load that data to production. When we went into modernization in 2018, we increased the frequency of data submission to 24 hours a day, 7 days a week, and then we loaded data, processed and loaded it on a weekly basis. But during the pandemic, we moved to processing it on a daily basis. Again, prior to modernization, our visualizations were often updated annually. And then during modernization, we started to update them more frequently, whether it was quarterly or otherwise. And now we've gotten it down to a month update schedule where we can see what's happening within a monthly time frame. The modernization and the ability to get data in there and process it more quickly, really, it accomplished a lot in the sense that hospitals with the capacity could report more real time. You'll see in this example that some hospitals are able to submit discharges that happened in September in September. And that is as real-time data as we're getting currently. There are smaller hospitals that are still experiencing a longer lag time, but the more data we can get in a more real-time basis, the more opportunity we have to run data analyses for policymaking in more real time. So where do we focus next? So discharge data, what we learned through this process is that we really need to look at the business process and also the flows at hospitals of how can we help or enable them to get this data into the system quicker. And when we talk to them, a lot of what they said is discharge data needs to be coded prior to submission to the state. And there's often a lag between discharge data and billing data processes. And many of you probably already know this, 5 to 10 days. And the coders also take a little extra time to look at the codes assigned within the electronic medical record system and then pull in other necessary information as needed. And so there's added intelligence about what is the primary diagnosis, what is the secondary diagnoses. And so that adds additional information that's valuable when you're analyzing and using the data. We also learned that staff at some of the hospitals can be part-time. During the pandemic, staff were furloughed, and that creates a backlog, particularly when hospitals are required to report to many different areas. And as we mentioned, there's variations between large and small facilities. So where do we innovate next? We need to start looking at how can we get the data from the hospitals in a more easy fashion. And one of those areas that that has been talked a lot about throughout this whole conference is the electronic health record, and being able to use some of the new standardizations or standard forms for bringing that data into these kinds of data warehousing systems. And one of the things, the opportunities that the all-payer data warehouse brings is just the environment of bringing the ability to bring these disparate kinds of data together through master patient index and other kinds of tools, standardization and enrichment tools, so that we can leverage the data for policymaking. So thank you very much. If you have any questions about the all-payer database, you can visit our New York State Health Connector website.
Excellent. Thank you so much, Natalie. And so now we have Natalie and Joe available to us to ask some questions about this important work. One question to get us kicked off. Tell us a little bit about, is there a use case that comes to mind for you when you thought, wow, we have really made a difference in this fight?
Hi, Mary Jo, can you hear me just to make sure?
I can, yes.
Thank you. I think the use case was regarding length of stay for patients in the hospital. We had another system stood up that collected daily census information on how many folks were admitted, what some of their information was as they were going into the hospital. But it really was the hospital discharge data system that allowed our research scientists to understand how long folks were staying in the hospital, how long folks in the hospital, length of stay, those that were being intubated, was there a difference between that and other types of stays, et cetera. I think the other one was just hospital capacity generally against the backdrop of years past. There was regulations put in place where elective surgeries were changed mid time frame during the pandemic, and we were able to do some benchmarking about the capacity within the hospital given those areas.
Great, thanks, Natalie. One more question for you. What data elements are used to build your master patient index?
We have several different sources of data that feed our master patient index. There are some slides on the Health Connector which discuss our master patient index much more thoroughly. Obviously, we use many different kinds of demographic information, names, addresses, Social Security information that is kept separate from the information of public or protected health information, so that we don't, we are always protecting the privacy of individuals, but that most of those core characteristics make up our master patient index. Matching.
Great. Thanks, Natalie. All right. Well, time for our next video. This video is going to feature Benjamin Fisher. So Ben is a research and EMS data specialist for NEMSIS. Prior to joining NEMSIS, Ben worked for the Arizona Department of Health Services Bureau of EMS, and there he oversaw both EMS and the trauma registries. Interestingly, Ben has also been a paramedic for the past 12 years. What I think is really interesting about this presentation, Ben's going to talk to us about the role of EMS data in the health data ecosystem and share some potential new and novel linkage projects for you to explore.
Good afternoon. My name is Benjamin Fisher from the National EMS Information System, NEMSIS. I'm going to talk to you today a little bit about what we do and some of the products we provide, as well as some of the things we hope to provide in the near future. I'll start with a policymaking example because I think it's a pretty salient one. Over the course of 2020 to present, each week we've produced this report publicly on our website that includes influenza-like illness, as well as some other clinical metrics and operational metrics like ED wait times for ambulances. The data we have is very timely. I'll speak a little bit more to that. And we've confirmed that it's a fairly accurate bellwether and correlates very closely to CDC confirmed cases of ILI, as well as some other metrics. So we think it's a really useful data set. It's very timely, and it's collected at the point of patient care. So it has some advantages that hopefully I'll touch on here in just a little bit. But again, this report is publicly available, and I think we'll kind of highlight some of the opportunities for use in policy making that EMS data can really have. So what is NEMSIS? We are the nation's emergency medical services data repository. The data is collected at the time of patient care on a Toughbook or tablet by an EMT or paramedic, or immediately after the time of patient care. And it also defines the data standard for EMS data collection, so the technical data elements in XML, as well as the elements themselves. Data travels from an EMS agency at the point of care to a state office of EMS. This is a little bit of an exercise in federalism. And the state office of EMS may collect a slightly larger
universe of data elements, and then the national elements are sent to us at NEMSIS. So from agency to state and then on to the national EMS database. I mentioned before the data tends to be very timely. We receive 50% of it within about 3 days, 75% within 10, and usually the rest of it within about 30 days. So it tends to be very timely in terms of the data we're receiving. NEMSIS was created with the first uniform EMS data set in 1994, and then shortly after September 11th, initiated what is now the NEMSIS program and asked states to submit data in this uniform format, with the Technical Assistance Center, the people and staff, coming shortly thereafter. Fast forward to 2019, broke 100 million EMS records in the database, and that brings us to 2020, where we broke 43 million records in the year across 12,000 agencies in 50 states and territories, and just below 20 million 911 responses with a transport. So biggest data set we've produced and continues to grow. We have 50 states and territories submitting data to us. A couple states don't submit data, and a couple cities or agencies within the states that do participate may not send data to us, but we're pretty confident it's a pretty robust data set that is collecting across the country majority of EMS agencies and activations. The Technical Assistance Center is divided into 4 pillars. So the business front end provides customer service and technical support, supports states who are operating those state repositories, vendors, as well as our national stakeholders. We have a research arm that produces the public use data sets and provides research support and custom queries to our stakeholders, as well as a reporting arm that creates dashboards and supports the online data cube. And the data cube has data that is usually within about 2 weeks from present. And then obviously none of this would happen without our IT and operations team that supports all of the other activities as well. So in addition to the Technical Assistance Center, NEMSIS is the data standard for EMS. We're currently on version 3.4, with version 3.5 has just been released and soon to be implemented. The data standard is defined with states, software vendors, federal and local stakeholders, as well as agencies, both in terms of what elements should be collected, and then the technical standard for how those elements will come across to the different registries. NEMSIS defines all of the conceivable elements, even though we require some. Some may be required at the state level in addition to the nationally required elements, as well as optional elements that a state or agency could additionally collect in a uniform standard because we've included them in the universe of potential elements. We also do vendor compliance testing, so a software provider that's going to create a software that an EMT or paramedic would actually collect data with has to submit test data to verify that they can submit data in a compliant format, as well as software vendors who create a state repository product have to verify that they can receive those records and send them to the national repository in a compliant format. I mentioned some of these earlier. Some of the products that we provide are dashboards, our online data cube from our website, an annual research data set produced each spring for the previous year's data in various formats, and that's row level data, and then technical and vendor tools. So in addition to the above, there are database schema, XML schema, and schematron tools, mapping tools between versions as the elements change, and several white papers that can help support the data standard, and then technical assistance for all of those. The policy uses certainly aren't limited by this list, but I'm sure you can imagine. So public health surveillance, very salient for the last year and a half. EMS resource allocation, benchmarking, quality assurance, academic, clinical, and public health research. This data, because of its timeliness, its uniformity, and the fact that it's collected across the country, really make it a kind of a unique and very robust data set that we think can really be leveraged for a variety of uses. Future directions for us: we continue to link data between relevant data sets. So we're working with the American College of Surgeons to link EMS and trauma registry data. And then we're also defining data standards for linkages, so HIE data. Now, there's no API for national EMS data, so if you're an HIE, you couldn't link to us, but you could at the state level potentially. And we're hoping for a data standard that allows bidirectional data exchange. Something that EMS agencies are very interested in is outcome data to verify that their clinical care is appropriate. And we've discussed some of the concerns about the legal implications of that, and there is a white paper on our website that discusses those. And there's a link on our YouTube page that to a presentation from our latest version 3 conference that we just held about some of these standards. You can see it in the day 3 presentations from our latest conference. And then version 3.5 is released and in the process of being implemented. We expect software vendors to release their 3.5 products here shortly, and hopefully have agencies and states transition to that newer version that will make things a little bit smoother for clinicians here in the very near future. All of these resources and additional information are available on our website at nemsis.org. There's no www. The technical resources, how to request research data, as well as contact information for the staff are all available on our website. My contact information is available here. I certainly welcome any comments or questions, my email address, and additional contact information, including some of the other staff with their specialty areas, is available on our website as well. And I'm always happy to answer any questions that I can.
Well, great. Well, welcome, Ben. I am just absolutely fascinated by this data set and all the information that it contains. We have a question here. Great presentation. Can researchers request NEMSIS data that is identifiable, like name, sex, gender, address, to link to other health data sources at the patient level?
That's a good question. Unfortunately, no, not at this time. Our data that we get at the national level has actually been stripped of PHI intentionally. We are working on one project, though, with 5 pilot states' Medicaid offices to link by beneficiary ID and then blind it again. So kind of step in that direction, but not entirely. We are hoping to pilot some Medicaid data linkage in the near future.
That's excellent. And I'm sure that there's a lot that we can learn even from that de-identified data. So great to know about this exciting data source that is out there. Ben, as we think about kind of the learnings, the findings that you find to be most interesting from the data set, tell us a little bit about that.
Boy, that's a interesting question, and I could probably go on for a long period of time. I think the pandemic has really kind of emphasized the importance of some of this data, and I think that because we have such a robust standard and the data is so uniform across the states, it's really kind of limitless. We really try and support the researchers. So if you do want to request the research data, please go ahead. We're always happy to work with you to try and explain some of the unique areas of our data if there are things that require some explanation. And really hope that people can think of additional uses for it.
Excellent. Well, I've got about 3 projects in my head, so I'll be in touch. Well, thank you so much, Ben. Great to have you. And now we're going to move on to our final presentation of today. And this is with 2 of my favorite folks from Utah, although I have a lot of favorite folks from Utah, Sterling Petersen and Brantley Scott. So Sterling Petersen is a senior consulting analyst with Castell Health, where he aids in crafting value-based strategies for healthcare delivery. As you may know, Sterling was previously the lead analyst for the Office of Healthcare Statistics at the Utah Department of Health. Brantley Scott has been employed by that same office as project manager since 2015. He manages the APCD there and also the healthcare facilities database. And so today, Brantley and Sterling are going to talk with us about how the Office of Healthcare Statistics got really creative during COVID. And so, they had all this claims and eligibility data that was flowing on a monthly basis, but it was really just kind of sitting in staging tables. And they were saying, you know what, let's dig into that data and see how we can put it to work. So with that, let's go to their video.
All right, hello and welcome. My name is Brantley Scott, and with me is Sterling Petersen. Today, we will be presenting the work that we've done in Utah with how we've handled claim versioning. So there's a few slides here in the beginning I'll go through pretty quickly. And if you're interested, you can look at these slides later, but it just gives the vision, the mission, and mission of the Utah Department of Health, the strategic priorities. Here's some data sets that we are responsible for. Here's my information and Sterling's information. And again, review this later if you would like. But to get into our project here, some of the challenges that we face here in Utah, and I think you guys face as well if you work with APCDs, is there's several different ways that different systems handle claim versioning, and these different systems submit the data in different ways to the APCD. And additionally to that, here at Utah, we try and balance the workload of both those who are submitting data to us as well as internal staff resources. And so there's sort of a fine balance of how much time and effort we can put into this versus making sure that everything is perfectly correct. And so some of the actions that we've taken to overcome this challenges is first, we worked with the data suppliers to really understand their systems and how the data was being submitted. Then we developed code to flag the final version and the keep. So we have a final version flag and a keep flag of the claims. And then the last step is sort of a continuous step where we verify that the data being submitted is as expected. And we work to ensure that if any changes get made, we update and improve our code as time goes on. And then, so one of the things that we did is we created templates both for the medical and the pharmacy claims for data suppliers to fill out so we could understand how the data is being submitted. And we had 4 different scenarios. And the first scenario was just a single line needed a single adjustment. Scenario 2 was where a line needed to be completely removed from the claim. And scenario 3 was where an entire claim needed to be removed. And scenario 4 was when a line actually needed to be added. So on this next slide, we sort of see these 4 different scenarios for the medical template. And in the template itself, there's 4 different tabs and there's spacing beneath each of these different scenarios, so the data suppliers can fill out the template appropriately. But I've consolidated it here just for ease of viewing. And I know I say ease of viewing, but it's probably super small on your screen. But the things that I wanted to highlight is we have here these elements that are required for understanding claim versioning for us here in Utah. And in red, we have highlighted in words what needs to be done. And then we've highlighted sort of in this yellow, orange color, the specific element that we want to be adjusted. So in the first scenario, it's just this single item that needs to be adjusted. In the second scenario, it's this entire line that needs to be removed. In the third scenario, the entire claim needs to be removed. And then here's if you want to add a different scenario. So when we sent this template to the different data suppliers, we had 35 different templates that were returned. And of those, there was 8 or more different methodologies. And that's just for the medical template, not including the pharmacy template. And some of the differences you can see that we found is differences in how they listed the financials or quantities and claim reversals. Some of the version numbers were used in order. Some of them were used year, month, versioning, and some of them didn't use any versioning at all. And then additionally, Sterling will talk a little bit more about this, but there was two main ways that people adjusted the claims. That's either done at a line level or a claim level. And then one of the more interesting things we found is there was actually differences in claim control numbers, that some of the data suppliers either included a prefix or a suffix to the claim to indicate that it was like a reversal or an adjustment of a claim. And then lastly, one of the things that we did is, and this is an important step, that we validate the data as it comes in. Does the data as it's coming in look like the template says it should? And if it doesn't, reach out and clarify with the data supplier. Additionally, we want to make sure that the flags match with the expectations for the claim. So that was one of the things we checked. Also going forward, we check to make sure there's a reasonable proportion of final state flags and keep flags. And if there was ever 100% one way or another, that usually to me indicates that maybe something's wrong with the flag or the data being submitted. And then we've developed code to continually validate and check after each processing cycle. And this is really an ongoing process that is something we need to keep an eye out for, because data suppliers can change processing systems. They're going to have staff changes. And so it's just important to always keep a watchful eye on it. So I'm going to turn the time over to Sterling to talk about what he did.
Thanks, Brantley. So for the next couple of minutes, I'd just like to go over how we implemented this our versioning algorithm at a high level. So as Brantley mentioned, there were two major camps when it came to claims adjustment. There was the line level adjustment and the whole claim adjustment. And not all the versioning systems fit neatly into these camps, as I call them. There were the ledger-based approaches where there were credits and debits, and you had to sum them up to get the final payment figure. There were hybrid systems that had both reverse and replace at the line or claim level and the ledger adjustments at some points. But for the most part, they all fell into these two camps. Some data was versioned very clearly using existing fields. It was just a matter of sorting and flagging the data. But other data streams required a little bit of custom logic, such as getting rid of a prefix from a claim ID or a suffix. Luckily, the biggest players in Utah in the market have very clean, easy to use data and didn't require a lot of custom logic. So out of the box, just implementing line level adjustment and whole claim adjustment logic, we have really good results. Next slide, please. Well, we decided to implement the algorithm using pure SQL, and that just made it really easy to maintain and allowed us to work with our vendor in kind of an iterative fashion, because we were both using Microsoft SQL Server. As I mentioned, most of the Utah insurance market is covered by a few large payers, and they had clean data. So it made it really easy to get really good results. And the confession here is we're largely ignoring the ledger-based approaches that can be common in some data streams. But luckily in Utah, it's not a major player. Next slide. So we wanted to do this in a very non-destructive way. So we implemented two flags. We created a final state flag and a keep flag. The final state flag merely indicates whether a claim line is in its final state as of the date of processing. And the keep flag indicates whether it's a claim line that should be kept for analysis. So both of these function independently. As a simple example, if there was a claim that was submitted and then subsequently fully reversed, the original claim would have a final state flag of 0 and a keep flag of 1, and the reversal claim should have a final state flag of 1 and a keep flag of 0. As you can see, for most cost analyses, you probably only want to use the final state flag equal to 1 and the keep flag equal to 1. That would give you the final versions of everything. These next three slides, they just show some simplified logic of SQL code for the algorithm that we implemented. The first one shows the line level flagging, and the next slide shows the claim level flagging. Finally, the last slide shows how we implemented a keep flag. And we've stripped out a lot of the payer specific things here, but we're happy to talk more about out this code and some of the pitfalls that we ran into as we implemented this logic. Thank you.
Thank you. You guys have a good rest of your day.
All right. Well, welcome, Brantley and Sterling. Great presentation. So much really good information on claims versioning, which is something that all of us deal with in one way or another. What's interesting to me is, Brantley, I know that you've been working on claims versioning in various ways for quite a while in Utah, and yet it still seemed like you had some great learnings from this process. So what's something that stands out to you that, although you had been working in this space, was still kind of new to you that you discovered through this phase of work?
Well, thank you. I think one of the greatest parts, at least for my part, is getting that feedback from payers. It was interesting specifically to look at some of them that had prefixes and suffixes, because even though it's in the DSG, they're like, oh, this number should be consistent throughout the life of the claim. It wasn't for some of the payers. And so really, again, verifying your data, even though it's said one way, it's always important to verify the data. And I think that was one of the things that I learned, is just don't take anything for granted, but be able to look at the data and get both, responses from people, and use that to inform how you look at the data.
Great point, Brantley. We have a question from Betty Harney. What is the granularity of the checks on intake? So in other words, could you validate multiple versions of the claim or claim line?
Is that a question for me as well?
Or for Sterling? Who wants to take that one?
I can go ahead and take that.
Sure.
So, yeah, we do that on the intake process to see if, it follows certain guidelines for what we're expecting. I'm not sure exactly what the question was getting at, but with the logic that was built, it's based on actually the raw fields that get submitted to us.
Excellent. Well, we got one more question. How do you optimize your versioning to make it faster?
I can jump. As we kind of got started with this and implementing code, implement the algorithm we came, and which we know isn't perfect, right? So we're implementing, we're probably getting 80 or 90% of the way there, given how payers. But one of the things we were surprised to see, flags to the existing structure, was actually fairly quick. I remember started doing this, kicking off the initial runs, and thought, okay, well, I'll come back tomorrow. But it was done, 10 or 20 minutes. So in terms of uptime, at this point, it seems to, for speed, there doesn't seem to be a road to processing because of this.
Absolutely. Well, thank you both so much. I just want to make sure we also had a question on the game token. So I want to make sure everyone just saw the game token that went by. I know that's important too. Thank you all so much for joining us for today's presentations. I always think it's really interesting to hear more about the work going on behind the scenes to make the data ready for important policy analyses. So thank you all for joining us, and see you at the next session.